Everyone, let's have a
Morning.
word of prayer. Our Lord Father, God the Father, God the Son, and God the Holy Spirit. We say thank you for this morning. We say thank you for each and everything you have done for us. Father, we can't thank you enough, Father. But Father, you remain God, you never change. And we call upon you at this moment. As we have woken up early, Father, come and prepare for our future. We have committed our lives. We know that it is very hard to get out of the blankets. But Father, be with us, bless us so that each and everything we do can lead us to success, Father. And we continue to surrender our teacher who is going to take us through this lesson. Let us each and everything that he teaches us, let us keep getting it. Give him wisdom, give him knowledge, so that we can understand and get all that we are taught, Father. Continue being with us, guide us in each and everything, and at the end of it all, we shall live to glorify your name. I pray those in the name of the Father, the Son, and the Holy Spirit. Amen.
Amen. Thank you so much for the word of prayer. Good morning, everyone. Thank you so much for keeping time for our session today. Yes, so today, like we had agreed, that today we are mainly going to look at the section. We are going to look at the section in differentiation. So we are turning all our energy to look at differentiation. So that is what we are going to look at today. We are going to look at differentiation, and under differentiation, we are going to start with the second learning outcome, which requires us to differentiate exponential functions. So in our session today, we are mainly going to look at exponential functions. Now, when they talk about exponential functions, you are required to know the following things. So in your syllabus, these are the things that are required from you. One, you must be able to know how the sketch of an exponential function looks like. So we are going to look at how the sketch of an exponential function looks like, but also be able to state some of the characteristics. Then we are also going to look at how to generate the derivative of an exponential function using the concepts of limits and then derivatives. So when they talk about limits, then you need to go, whenever they mention limits, it means that what the idea you have to use is the idea of differentiating from first principles. So that is where we are going to look at how that thing comes about from the first principles. Then also we are going to look at how to deduce the general formula for differentiating the exponential functions. And then from that point, we shall go on and look at numbers, or we shall go on and differentiate exponential functions, both in trigonometric format, but also the general format. Now, when you look at my screen, when I write an exponential function is written in this form: y is equal to ex. So ex is the one that represents what we call our exponential function. So E stands for exponential, exponential. And when you look at exponential, when you look at your calculator, you can note that your exponential function is found where you have where you have where you have in, that's where you find your exponential. So that is what we are going to look at today. But what about in English? When someone tells you exponential, something is increasing exponentially. Exponentially in English means uh, becoming more and rapid, becoming more and more rapid. That is the meaning. So if you want, you can say that her performance is exponential. So meaning that her performance is becoming more. So that is what we mean by exponential. So exponential mathematically means something that increases at a rapid rate. So there are things that in life will increase at a rapid rate. Maybe an example is that when you become a bit how do you say it? Like when you become a bit used to certain apps, there's a way they consume your time. So you become a bit more addictive to them. Now, how do the sketch of an exponential function look like? Like you know that whenever you are drawing something in math, you always form your table. So we are going to first form our simple table. And in this simple table, we shall have the x values, we shall also have the y values, such that we look at the behavior. And whenever you want to study the behavior of a given curve, always draw it and make a sketch such that you can know how it behaves. So here I'm going to take on some values. Let me say I'm going to take on values from -2. I can take on maybe -1. I can take on my values of 0. I can take on the value of 1. I can take on the value of 2. And then I can take on the value of 3. So these values I've obtained, I'm going to substitute them in our exponential function of y is equal to ex. Now, where there is x is where we put 2. So I will say y is equal to e power -2. So you place it in your calculator. So in case you are going to place your calculator, make sure you place shift, then you place where you have linear. You say shift and then you place lean. Then that's how we place the exponential in the calculator. So when you put in -2, you end up with an answer of 0.135. But since we cannot plot this one here on the calculator, we are going to write it to one decimal place. When you place e in of -1, you notice that you get 0.4. I'm writing to only one decimal place. E of 0, you end up with 1. E of 1, you end up with 2.7. E of 2, you end up with 7.4. E of 3, you end up with something like 20.1. Now, what you do, we go back and do the plotting. Like the way you plot, you get your x value, plot it against the y. Now, for the first pair, we have -2 and 0.1. The second, I have -1, 0.4. The next one, I have 0 and 1. The next one, I have 1 and 2.7. So that's what we are going to plot. So when you look at -2 is here, I'm going to assume 0.1 is somewhere here. 0.1 is somewhere there. Then I go to the next one, 0 and 1. 0 is here and my 1 is here. I plot that one. When you look at, okay, -1 is here and 0.4 is here. This is my 0.4. 0 and 1 is here. 1 and 2.7. This is 2.4, 2.6, 2.7 is going to be somewhere there. Then this is 2 and 7.4. Oh, 7.4 is going to be up there. Okay, I know it is somewhere this side up to somewhere up there. Now, when you look at the nature of that curve members through the chart, what are you noticing? Is it a line? Is it a curve? Depending on what you are noticing. What are you noticing? When you look at the points of how we have plotted, which kind of shape are we forming? Jimmy is saying it is a curve. People are noticing that it is. Okay, people are saying it is a curve. So, and when they are curves, we use our free hand. So you can notice that our curve is going to come like this, like this, like that, like that. Then it goes. Then here it will come like this. Something like that. Now, members, this is what we call our function. This is the exponential function. So whenever you are dealing with an exponential function, your graph will always look like that. So curves of exponential function, more so when we have a positive, they look like that. So this is what we call an exponential curve. And therefore, allow me now, since I've showed you how to do it manually, allow me now to go to my tool, and then I show you its behavior. So you are going to look at how I'm going to be drawing them, and then you check out what is the effect. Take an example, the one we have drawn, y is equal to e x. Are you noticing its nature? I want you to take note. I want you to look at its behavior along the x-axis, along the x-axis. This is the one in blue, is the curve. Maybe let me change the color. I want you to look at the x-axis, its nature. When you look at it, you are noticing that even if I increase, if I'm extending the graph, members, what are you noticing along the x-axis? When you look at that line, even if I continue increasing this side, are you noticing it? Are you noticing its behavior? That it is along that x-axis. It says at 0. Very good. And then when I come this side, I wanted to also show you this side, even up. When you look at up, you can go, you can go. So when we go up, it will go continuously without touching the y-axis. So that is how this curve behaves. I want you now to check. I'm going to start, are you seeing this power? I'm going to change the power only. Take an example, when I put 2x, I want you to check on the behavior of the curve. I know some of you have not seen. That is when it is x. So when I put 5, I want you to check out what happens. That's when I have put 5. What have you noticed? Members, when we put 5, check out what happens when you put 5. What happens? Did the members observe, or I first take back? I want you to check when I put 5x up here. Let me first put it back. Let me first remove it. So I'm going to put x. Have you noticed? So when I put a power here, let me say I have put 7. You'll tell me what you observe. Sorry, now I've changed the curve. When you put like something like 7x, you look at how the curve behaves. Very good. The curve reduces. It comes closer to the y-axis. Very good. Very good. What about, now I'm going to put another curve here that I want you to look at. What about when I put, we draw a curve of e power negative x. So members, are you seeing that curve? Whenever it is for negative x, have you looked at its nature? So when it is negative x, it is this one in blue. It is the one in blue. That's how it looks like. So you need to know, if my curve is of negative x, if I have a power of negative x, how does it behave? If my curve is of this nature, how does it behave? Also, I want to put negative, I want to increase the power here, maybe 7, and you look at its nature. What happens? So you notice that whenever this power becomes bigger, it becomes closer to the y-axis. What about, I want to put a number here. I'm going to, let me remove the 7 and I put a number here, and then you check out what happens. You tell me what has happened. I have put 5 instead down here. I'm going to put another value and you check out. Let me say I put 10. Check out what happens on that curve. Look at the red curve. What have you noticed on the red curve? Look at the red curve is the one I'm changing. I'm changing the values here. You look at my screen. Extends away from the y-axis. Let me continue adding such that members can be able to notice. What about when I put 19? The change goes to the negative side. You look at how it is shifting. Now it shifts. It shifts into this side. Now that is the impact of those curves. But the curves I want you to know is that whenever it is a negative, the same thing happens to that blue one. If you put here, let me say 5, you'll check out that for it to shift towards the y-axis. You put things like 19, you'll find that it's going to shift. So that one, now you need to know that when I put a value here, it shifts. Yes. And if you continue here placing, like, let me say on the positive one, time can come whereby, let me say I put 80. You will notice that the curve will shift will go on shifting and it enters into the y-axis. So members, in your book, can you draw a sketch? Yeah, you can draw rough. Okay, you are going to draw how this nature of this curve when you have y is equal to x and when you have the other one for positive, how they look like. So you need to know that when it is x, it looks like this. When it is this, it looks like this. And also, maybe let me also draw for you. What about when I have a fraction? What about when it is a fraction? Let me say 1 out of x. Have you seen the nature of that one? In case it is 1 out of x. Have you seen how it looks like? Let me delete these ones such that members can see it very well. So that is what happens when it is 1 out of x. When the power is 1 out of x. For it, the curve looks like that when it comes to those exponential ones. Okay. I'm going to go back on my thing and then we continue. Members, let me hope. Are we on the same page? Are we on the same page? Yes, okay. Can we now draw what we have on the board here, roughly, and then we continue? Yes, Roger. Okay, okay. Uh, eh, okay, okay. Yes, Rogers, your hand is up. So members are sketching this curve. Yes,
Good morning, teacher.
morning.
I'm just asking if is this topic
Hmm.
or differentiation or vectors?
Differentiation.
Then, because I'm seeing in the chat that we are continuing with the differentiation, had we studied this topic earlier before we joined?
Yes, yes. We studied it some 3 weeks back.
Like how many lessons?
This is, I think, the 4th lesson.
Okay, I will check out on the YouTube, then I get other lessons.
Okay. Okay,
Thank
okay, all right. Okay, So members, now we are going to state some of the features. Now, when we are stating the characteristics of an exponential curve, we are stating the features. What I want you to look out for, you look at the behavior you look at the behavior of the x-axis, the x values and the y values. When you look at them, what is happening? That's how you can now state the what? The features, or the characteristics. What happens for the values of x and the values of y when you look at them? So can someone tell us, even if you just look at the table here, you can just look at the table, look at the values of x and the values of y. Which kind of relation is existing between those values? Or what do you notice? Can someone discover that? Look at the nature of the curve, look at the values. The value of y go on increasing. Thank you, Jovix. What about the value of x? Remember, when you are stating, you look at both. Now the value of y is increasing. What about the values of x? Uh-huh. Increase in y increases the x. Thank you, Jimmy. I don't know whether members we are noticing that. Whereas the values of y, remember this, when I am moving this side, the values of x are increasing. When we move up, the values. So you notice that when you are moving this side, the values are increasing. But also, when you move up, the values are also increasing. Even if you look at the table, the values of x are increasing, when the values of x are increasing, the values of y are also increasing. Because -1 to 0 is an increase, it is an increase, it is an increase. So one of the features of this exponential function, whenever it is positive up here, even if it is e power 2x, whenever it is positive, an increase in the x results into an increase in the y value. So that is what happens. An increase leads to an increase. Whereas, as this one, you'll do it in your free time. If you look at the second one, like this curve, we say that will come like this. And we say this is when y is equal to e power negative x. If your curve is of this nature, you notice that what is happening for it, I want members to just check out for it. You check out these are the y values, they are coming down, and the x values are coming this side. Members, what do you notice when it is negative? When we have a negative ex, what did you notice about the nature of the y values and the nature of the x values? These are the y values, these are the x values. What are you noticing about those ones? The x values are on increase. I want someone to look at them very well. The values of y and the values of x. What do you notice for this green one? X increases, Y reduces. Very good. Now you need to know the nature. So the nature of the characteristics will always depend on the kind of power you have here. When it is positive, an increase and an increase. In case it is negative, it is a decrease and an increase. Members, let me know whether we are okay with the exponential curves such that we can now continue. Is everyone okay with that? Are we good to continue with an exponential curve? In case you have any question, you may ask before we move on. People are, yes, okay. Samsung has a question. Yes, Samsung.
Good morning, sir.
Morning.
Sha, I'm sorry I've come late today. Would you help me and summarize a few that you had been talking about under exponential functions?
Okay, we have said that what we are doing is we are trying to draw a sketch of an exponential function. And when you look at our table,
Yes.
after feeding into our table, we got our values and we plotted them. So this is how our curve came about. And what we are saying that whenever you have an exponential function, you get a curve. So one of the characteristics is exponential functions yield curves. Number two, if it is a positive function, you notice that the values of x are increasing and the values of y are increasing. So that is the
Yeah.
second good thing about this curve. So that's why you have found us, but also we looked at the nature of different curves, but we use the software. So we have not drawn them here. So that is briefly what we are
Okay.
going to look at.
Okay, sir. Thank you.
Okay. So, okay. Now, members, was our first aim for this session. Then the next we are going to look at, members, you have noticed that when we draw our exponential curve, this is what we came up with. We came up with something like this. Now, along here, this is where we have our y. Along here, we have our x. But mathematically, when we are writing, I'm going to say that I'm going to take this point here, members, to be my x point. This is automatically 0. Now, we want to find out how does this curve behaves at different points. Now here, I'm going to come here and I write here that this is going to be my x plus a small change in x. This is my increment from x to x plus change in x. Similarly, when I come along the y-axis here, remember this is y, and mathematically y is the same as your function f of x. Now at this point here, I'm going to have my f of x. Then at this point here, I'm also going to have my f. But what is my corresponding x? My corresponding x is x plus change in x. So here I'm going to have my x plus small change in x. What are we doing? Literally, where you have x is like how we have 0, 1, 2, and the rest. What does it mean? It means that when your x is 1, what is the value of y? The value of y is what we represent by function of x. When we have 2, what is our value of y? Is what we represent by this kind of what? Function. Then when we talk about small change in x, we are asking ourselves, from this value here up to here, by how much did you increase? That here, we increased by a 1. So we added a 1. So for this case, your small change in x is the plus 1. So that's what we are doing. And why are we doing so? We want to come up with a derivative. We want to come up with a derivative because I told that a derivative is a gradient when we are starting this topic of differentiation. So that's what we want to come up with. So I'm going to clean my screen. Now, when I clean my screen, you will notice that when I draw here a line, and I draw here, you know very well that this one is our corresponding change in the y. So this is what I'm going to call a small change in y. Then what I have along here is what we call a small change in x. So in mathematically, this is what we call a change in y. Mathematically, this is what we call a change in x. But since we are talking about in terms of differentiation, here I'll call it small change in x. I'll call it small change in y. Can I first know whether we are still on the same page? Are we still on the same page? I want to know. Yes, yes, yes. Okay, very good. Okay, so we are going to continue. Now, as we continue, I want to bring to your attention that in order for us to get our function, our dy dx, I'm going to come and I say our dy dx dy dx. If you don't want to use the dy dx, you can use your function f prime. Is going to be given by the limits as our delta or change in x tends to 0, change of y out of the change in x. Hope you know that very well from your differentiation. That if you want to get dy dx the same as the limit as the change in x tends to 0 of dy dx. Now from here, you notice that what is your change in y? When you look here, our change in y, like change means a difference, means I'm going to get this value here, which is f of x plus delta x, or change in x, minus f of x. That is our change of y. When it comes to f of to change in x, change of x, what does it mean? It means that I get this value here, which is x plus change in x minus x. That is the meaning. So I'm going to come here and I say, here I'll have my limits as the delta x or small change in x tends to 0. I substitute for my change in y, which is going to be f into x plus minus f into x divided by our x plus change in x minus the x. So mathematically, we shall continue and say this is the limit as delta x tends to 0. Up there, we shall remain with f into x plus change in x minus f of x. Everything divided by x minus x gives you 0, and therefore we shall remain with delta x like that. But you are going to ask yourself, which function is this? Members, the function we are plotting here is the function f of x of our exponential function, because this is what we plotted. Now, what does it mean? It means we are going to substitute. We are going to substitute in here. I've removed those ones because I want to write here. Now, when I come here, I'm going to substitute. So we have our function f of x is equal to e of x. Now, for the first one, I have f into x plus delta x. So when we substitute, it means we shall have e x plus delta x. So that means that where I have here in this position, where I have f into that, I'm going to substitute with that. Then where I have f of x, I'll substitute with this. So I'm going to go in my function here and I say now my dy dx will equal to my limit delta x tending to 0 into e of x plus delta x minus e of x, everything divided by delta x. Now, what do you need to know? You remember from your mathematics is that when I have e of x plus delta x, mathematically, this is the same as e of x times e delta x. Remember your indices that if I have ab dot sc, mathematically, I can add the two. So this is the same as a B plus C. Similarly, E is the base. So when I have EX plus this, I can write it like this. So in the position where we have this, I'm going to write it in this format. So I'll come here and I write it now again that this is going to give me my limits as delta x tends to 0 into E of x, E of change in x minus E of x, everything out of the delta x like that. So what are you going to notice? This is the same as the limit delta x tending to 0 into. Now, when you look very well, you notice that this and this are the same, meaning they are this common. So I can pull it out. So when I pull it out, I'll get E of x into E delta x minus 1, everything divided by delta x. Then I put the bracket. Yeah. May I know whether we are still on the same? Up to that point at least. Okay, okay, this is very good. This is very good. Now, I'm going to extract something and we first study its behavior. From here, I want to only extract this. I want to extract this and we first study its behavior. So, if I have E delta x minus 1 divided by delta x. Now, to study the behavior of something, I told you, you use a graph. You use a graph or you look at the values of in the table and then they can tell you how that particular thing behaves. So I'm going to draw a simple table. In my table, you are going to allow me that here the things that are changing is this delta x. So I'm going to have my delta x. Then down, I'm going to have E of delta x minus 1, everything out of the delta x. Now I want you to check the behavior when we substitute different values for the small change. So take an example. I can have my small change. Let me say, you can start from any value. Let me say I've started from 0.1. Members, you substitute 0.1, put it here. When your small change is 0.1, put it in your calculator and see what you get. E of 0.1 minus 1 divided by 0.1. My calculator here gives me 1.052. I can continue. If I have another small change, let me say I have 0.01. Still feed into your calculator and see what you get. You say E of 0.01 minus 1 divided by 0.01. So personally, I'm getting 1.005. Feed in another value, say 0.001. Remember, small change in x is a small increment. So when you put in E of 0.001, minus 1 divided by 0.001. The answer I'm getting down is going to be 1.0005. Members, I want you to observe what is happening as we are increasing, as we make this small change x smaller. What are you noticing on the result of this function? What is happening? What is your observation about the value we are obtaining? I want you to check. For you, keep on, even if you put 0.0001, someone says it decreases. Observe very well. Do not make a same assumption. I want you to check out the behavior of these values you are getting. They are decreasing. They are decreasing. Look at these values here are the ones I want you to look at. They keep on reducing. Zero goes on the zeros goes on increasing. And now if I may ask, if we keep on increasing 0.000, which value do you think we shall tend to when we reach those last ends? Thank you, Favor. Alice has said we shall tend towards a 1. Very good. Reduces slightly. Yes. So members, the more values we keep on increasing for small change, time is going to come when the answer we have is 1. And therefore, I want to bring it to your attention that the whole of this thing here, that let me take it here. So I'm going to come and I tell you here that the whole of this is going to tend to 1. And therefore, we shall say that as delta x tends to 0, the whole of changing x minus 1 out of this delta x will always tend to 1, like how you have seen its behavior. Therefore, when I come back here, where I have the whole of this, I will put just 1 because it tends to 1. And therefore, what shall we have? So I'll come back and I say, when we substitute here, it means that now our function, our dy, dx, is going to tend. So the only thing we remain with is going to be e of x. And members, this is what we get when we differentiate our exponential function e of x. Yes. So that is what I wanted you to check out. Yes, Dr. Jimmy.
Good morning, Master.
Morning.
Master, there where we having the e to e of delta x minus 1 out of delta x.
Mm.
Some books use the series of ex,
Mm.
and when we use the series of ex, we find out that inside there it will be inside
Mm-hmm.
it will be 1 plus
Mm-hmm.
delta x squared out of 2. I mean out of 2 factorial
Mm.
plus, and it goes on increasing like that.
Mm.
Then when we substitute in the ex, when we multiply by the ex because it is out,
Mm.
we find out that the ex the first ex's will cancel, and then the rest
Mm.
will the first one will have ex delta x, and
Mm.
the next one will be ex delta x squared divided by 2 factorial.
Mm.
Then when we divide by delta x, we shall by the end of it all we shall remain with ex,
Mm.
as we have done here. I don't know whether
Oh,
that one is also okay.
okay. Now that is the second approach, but since your syllabus book wanted you to start from the graph, so when you are using the graphical approach, this is how you approach it. But if I was using that approach, if I was using this approach of, if I had used from the first principles, like by adding y plus changing y is equal to a x plus changing x, then that is okay.
Okay,
That is very okay.
okay, Master.
Mm, that is very okay. So you can go and use and expand the series and know that e of x, when I expand, I'll get 1 plus that, plus this is changing x, plus and so on. It is okay. It's okay. Mm, But since they wanted graphical approach, the syllabus emphasizes the graphical approach. So that's why I stick to the graphical approach.
Okay, thank you, sir.
Okay. Yes, Samsung.
Good morning, sir.
Morning.
My question is on this last formula that you have got under exponential functions.
Mm,
Is it the one that we shall always use when dealing under differentiation and dealing with the exponential functions, or still we follow this other one that where you have started from in order to derive this?
Oh, we are going to look at how we are going to be differentiating, but I wanted to show you how you differentiate from first principles and why when we have the y dx, remember our y here was an exponential. So when you differentiate this exponential, you get exponential. That's the first thing I wanted everyone to know. That whenever you differentiate an exponential, you get an exponential. Then the other methods of differentiation we have been using, they will still apply.
Okay.
So members, are we good to continue? Should we continue? Yes, Tricia, that assumption is very okay. That whenever you differentiate an exponential, you get an exponential. And even mathematically, it is one of the function whose behavior is bad. It misbehaves a lot. This function of an exponential, it has bad behaviors. You differentiate it, you get the same thing. Even when you integrate, you get the same thing. So it is that function whereby whether you add or like, I don't know that you have seen those things. You add, whether you add or you reduce, you remain with the same thing. So that's how that function behaves. You differentiate, you get the same thing. You integrate, you get the same thing. So now, can we derive the function? So I want to bring to your attention now, how do we get the general format? Now I'm going to say, or you'll allow me to say, sorry, you are going to allow me to say that if my y is equal to an exponential f of x. Now members, we know very well that when we are differentiating something, like I've told you, you need now to know that whenever you have ddx of an exponential, you also get that exponential. That's the one thing you need to know. Now you are going to allow me to say that let my u equals to my power here, which is f of x. And now you're going to allow me to write my function y is equal to e of power u. Now here, members, doesn't matter whether it is u, whether it is x, as long as what you have here is just 1. As long as what you have up here, it is 1. That's what matters. Now you have seen that here I've changed the variables. So we are going to use our chain rule. And you remember our chain rule tells us that dy dx will equal to dy du then times our du dx. Now I'm going to come here. I'm going to differentiate u. When I differentiate u, I'll have my du dx. Now, when I differentiate this function, I differentiate it with respect to x. I write it as f prime of x. Then when I differentiate this with respect to u, I'll have dy du. But I've told you that the moment you differentiate e power u, you get the same thing of e power u. So that means here, members, we shall have our dy dx equaling to dy du, which is e power u, times our du dx, which is f prime of x. Now, which we can now write as our dy dx is equal to f prime of x e power u. But what is our u? Our u is f of x. So here I want to write f of x. And I want you to, from today onwards, to know this concept. That whenever you meet an exponential function and you are differentiating it, what do? You look at the function you have up here, differentiate it, then after write the original function. Differentiate that function, write it there, after write the original function. Is that okay? Is that okay, members? That is now the general rule. Whenever you meet an exponential function, for you differentiate it first, then write the original thing. We are going to look at an example such that you people can look at it very well. Yes, Baswali.
Good morning, teacher.
Morning.
Teacher, I beg for your pardon. I'm not understand, teacher. I delayed a bit to join.
Okay, allow me. We are going to do some examples. and we are going to look at how we differentiate. Then I want you to pick from that point that whenever you are differentiating an exponential function, at this point here, we are using our chain rule. And when you are using the chain rule, look, you change the variables. So for our power of u, we said is equal to f of x. When you differentiate u with respect to x, you get du dx is equal to f prime of x. Then after, where there is f of x is where we place our u. When you differentiate the y du, you get e power u. Because we have derived that whenever you differentiate an exponential function with respect, when these two are the same, you get the exact thing. So when we fill in, we get this, and then we substitute. But we are going to look at an example, and I know it will click very fast. Okay. Members, are we good to continue? Differentiate the power, then write the original function. Good. Okay. But remember, okay, I'm going to first put part A. But still now, when you find it and you are differentiating, take an example. We have y is equal to e power 3x. What do you do? I'm going to first show you how we do it, but I want you learn it very well. Don't just write the answer. In case now they want you to show the working. So here I'm going to say that let our u equals to the power, which is 3x. So that means that in order for you are going to use your chain rule. And we know that chain rule tells us that dy dx will equal to our dy du, then times our du dx. So here it means I need my du dx. I will say du dx. You differentiate, we shall get 3. Then we know that our y will equal to e. Where there is 3x is where we put u. So it will be eu. So that means your dy du will equal to eu, because I've told that the moment you differentiate e power u, e power x, you get the same thing. Then we substitute. So we shall have dy du, which is e power u, then times du dx, which we obtain as 3. So we can write this as 3 e power u, but our u is 3x. So we end up with 3 e power 3x. Now that's how we differentiate. And what are you noticing? That it is just a matter of you looking at what you have here, differentiate it, you get 3. Then write the original thing. Okay. Let me give you one here. And members, differentiate for me. You are going to differentiate for me this e power 5x. You tell me what you get. Tyler, tell us, what did you get? Mhm. Mm. Gilbert has got 5 e power 5x. Good. Perfect. Yes, Ruth. Yes, it is okay. We are allowed to do it directly, unless when it is a number independent. If it is a number that is independent, then you show how you are coming up with the answer. But I know you are going to be differentiating things, those numbers, and you'll find that the thing is already there. You just need now to apply the concepts. Yes, Khan.
I was just trying to tell you the
Okay, tell us for this now, Khan. I have put another one. This one differentiate for me from the head. Y is equal to this. What could be our answer? It is?
It is 10, yeah, then then exponential 10x.
It is 10. Exponential.
X.
Not yet safe. Not yet safe. Members, I'm looking through the chat. We are not yet safe, Jimmy. Gilbert, yes. Dr. Peace, yes. Fidja, yes. Eh, are you seeing Jimmy? Doctor, are you seeing? Differentiate
Yeah.
this. Eh, Linda, we are not safe. Linda, we are not safe. Yes, Dr. Jimmy.
Master had made a mistake. That one, that two, I have forgotten to multiply it with a 5.
Oh, okay, okay. So members here, your answer will become 10x e 5x power 2. Okay, okay, okay. So that's how you differentiate those kind of functions. Okay, so we are going to continue. We are going to continue. Okay. Okay, number 2, that was yeah. Now, I give another example. I have 5e power negative 2x. Yes, 5e power negative 2x. Are we doing it? Let's first do it. Yes, Melissa, that is okay. Jovix is okay. Christine, yeah, yes, yes. In case you feel a bit stuck, raise up your hand. I've given you part B that I want you to differentiate for me. I'm going to wait for the answer in the chat. But in case you feel stuck, you let us know such that we can help. Hmm. Hmm. Yes. So I'm seeing some answers. Okay. Very good. Very good. So still you can follow through the same procedures, eh? The same procedures. You can say, yes, Moses.
Sir.
Yes.
Yeah. Teacher, me, I did the first example, since it never had the power, and my answer was 5e power 5x, and I think I was right, but this one with the power, I'm having challenges, sir.
Okay. Okay. You stay
Mm,
on. You stay on.
okay.
So the first thing we shall say that our y is equal to 5e power negative 2x. Now,
Okay.
whenever members you are dealing with research, you look at this power. So I'm going to say that let my u equals to negative 2x.
Okay.
Now, what you do next, since we are going to use the chain rule, you said you get your dy du dx. So I will say
Yes.
my du dx
Dx
will is
equals
equal
to
to negative.
negative 2x.
Very negative 2. Remember, you have here there is a power
Oh,
1.
yes, teacher. Yes, teacher.
Then we come back here. We say our y was now 5e power u. Because we said
Yes,
negative 2x is equal to u. Now, this 5
yes.
is a constant in differentiation, so it doesn't matter.
Mm,
So we shall now
okay,
say the y du is equal to 5e power u. Have you
okay.
seen? Eh.
Yes,
Now, when we go back, we have our dy dx equaling to our dy du, then times du dx. So you substitute in your dy du, which is 5e power u times our du dx. But our du dx is negative 2. So
mm.
when we multiply 5 times negative 2, what do you get?
Then,
10. So I'll have
yes,
negative 10 e power u, right?
thank you so much, sir.
Then you substitute for what your u is. So your u will become negative 10 e and your u becomes negative 2x. Is that fine?
Yes, teacher.
Okay, okay. So members, let me hope you have noticed, like even if you have noticed that as long as here is just a constant, for you differentiate this, negative 2x, when you differentiate, you get negative 2, then times the 5, such that you get negative 10. Now in the chat, this is a quick one. Okay, now here I have another one. I have y is equal to, let me give you, I have 10e power 2x squared. This number, I'm going to ask, I know on our call, we have, I know we have some schools that are already on the call. So I want to welcome the students of Biguli SS who are on the call, and I'm going to ask them to get for us some people who are going to have this quick math of telling us the answers. So I'm going to ask, you just pick one or two people, and they tell us which answer they are getting. So Biguli SS, you are welcome. So I want to ask teacher to unmute, and you get for us two students or three, and they tell us the quick answers. Okay.
Yes, Stephen, we have already unmuted.
Okay, thank you so much. Can we have one student tell us which answer we have here? A quick one for
So
you, DYDX.
the answer is
Mm-hmm.
for x,
4x,
for the
uh-huh.
x,
40x,
yes, exponent to x squared
exponent
to x squared.
to x squared. Very good. Thank you. Can we have another one to tell us also a quick one? Our y is equal to 5e of 10x.
Anyone else? You come close and
dy dx
The y dx is equal to
50
50
exponent
exponent
10x.
10x. Thank you. Can we have a girl at least also? We have a girl. Okay, we can have a girl at least come and do for us this. Hey, let me unmute. Yes, we can have a girl.
Our dy dx is equal to 12
12.
exponent x cubed.
Exponent. Oh, sorry. Is equal 12.
Exponent x cubed exponent x cubed x4.
X4. Okay. Thank you. Okay. Thank you so much, Biguli SS. Yes. So members, we have been doing a quick one. So I know when you keep on mastering and differentiating, the moment you be reaching these exponentials, yes, you look at the function and then for you just crush it. Okay. Now we continue. We are going now to look at another. We are advancing. Now there are some times. Now this is our third example. What about when I have ex? I have x here. Let me put it as x squared. I have e of 2x. Now, once you find that your function is composed, because remember here you have to differentiate x and exponential, what do? You have to run very quickly and remember your product rule. Remember our product rule, we say that when we have y is equal to uv, in order for us to get our dy dx, we shall always say v du dx plus your u dv dx. Now, whenever you find such, that is the concept you have to use. So what are we going to do? We are going to let this to be our u and this to be our v. Then we are going to apply the rule. So we can start. So we are going to say that our u is equal to x squared. And when you look at our formula here, what do we need? We need to obtain du dx. So we shall come here and differentiate and say our du dx will equal to, so you drop the power, which is 2, then reduce the power by 1, so which is 2 minus 1. And therefore our du dx will end up becoming 2x. 2 minus 1 is 1. So any number to power 1 remains that number. Then what about our v? Our v, we have said our v is e to x. In the chat, a quick one. What is e to power 2x? Now, this is where we say now that is a quick one. We just put the answer there and go on. Uh-huh. Yes. I'm sorry, I forgot to plug the router in the sockets. So the battery got finished. Yeah. Okay. So we are going to continue, but I know you had continued. So our V is equal to E to X Our du dx from here is equal to, so we are multiplying times 2x plus our u, which is our x squared, times dv dx, which is 2e2x. Now, it is always a good practice. You start with this, then you write the exponential. So I can write 2x e of 2x plus, here still write the digit first, 2x squared e of 2x. Now, this is your answer. In case you have time and for you want to put it in a given form, it is as well okay. Because when you want to continue, 2 is common here. You can notice that 2 is here, 2 is here. X is here, there is an x here. E2x, E2x. So you can factor them out. There's no problem. So you can come and say now, I want to factor out a 2. I want to factor out an x. I want to factor out an E2x. Now, when we factor them out, you are going to notice that here, this 2 has gone away, this x has gone, and this one. So you remain with a 1. Here, the 2 has gone away, 1x has gone away, you remain with x, and E2x has gone away. So here it means that we are going to remain with just 1 plus x. And therefore that is it in a very simplified format. Are we good to continue? Okay, very good. Okay. Now we are going to look at here. Remember, the rules matter. The rules are going to be very important. Okay. Let me give you another one. We have y is equal to e power 5x out of x power 3. Yes. Members, which rule are we using here? Which rule are we using here? Which rule are we using? Quotient rule. Very good. The quotient rule. Yes, very good, very good, very good. Why don't I allow it first try it using the quotient rule? Yes. Can you first try it using the quotient rule? Still, I will invite Biguli SS. Someone will take us how you're running it. So still this one, I will invite Biguli SS to take us through the quotient rule. Those who have forgotten the quotient rule is that one that helps us whenever we are dividing. So you have your u out of the v. You have your u out of the what? Out of the v. So we shall have someone from Biguli SS to run us through this at least. Even I don't know whether the Gavanians are around. I'm going to check. Gavanian? Okay, so just to remind people, in case those who have are forgetting our quotient rule, we said it is dy dx is equal to, always we start with v, don't forget v du dx minus your u dv dx out of your v squared. So don't forget that always. And God forbid, sometimes when we are working on pressure, things tend to freeze sometimes. So for such cases, you run very quickly in your logbook and then you check out. In case things are not working out. But I know we are trying. So let me be calling on Biguli SS We'll have one student to be running us through as everyone else is trying.
Good morning, sir.
Morning.
Yeah, we're going to start. We're having y equal 5x, then x cubed. So on defining, my u is e power 5x.
Good.
Then my du dx will be equaling 5e or 5x.
Okay, good.
Then my v is equaling x cubed.
X cubed.
Then my dv dx will be equaling 3x squared.
Okay.
Then from du dx equaling dy dx equaling
Okay.
v du dx minus u dv dx out of v squared. So I will be having my v was x cubed. My du dx was 5a or 5x, then minus my u is e power 5x, then times 3x squared out of x cubed square, x cubed then squared.
Okay.
Then on arranging, I'll be having x cubed, 5x cubed,
Okay.
e power 5x, then minus 3x squared, then times e power 5x out of x or 6 x. Then I'm going to pull out the common ones. I'm seeing on all sides x squared
Okay.
and e power 5x are common. So I will remain with x 5x minus 3
Okay.
out of x power 6. So I can reduce and I remain with e power 5x into open brackets 5x minus 3 out of x power 4.
Wow. Thank you so much. Thank you so much. Yes. Yeah. Hope members were also there. Yes. Thank you so much, Bigly SS. Okay. So I'm going to pick some hands. Rogers, Dr. Peace.
Good morning, teacher.
Morning.
Okay, good
Morning.
morning, sir.
Morning.
Teacher, I'm just asking about the formula. So after writing the formula, can I go straight to substituting? If at all I can differentiate the stuff from my head, yeah? Like if if I know that maybe if I differentiate e power 5x, I get this. If I differentiate x cubed, I get this. Without going through that that step of finding du dx, dv dx, what?
Oh, okay, okay. But what I would recommend, at least have these ones on the side somewhere,
Okay.
such that you show where you have obtained them. Because in the formula, you're just substituting what you have already obtained.
All right, teacher, thank you.
Okay, okay. Yes, Rogers. Rogers. Okay. Dorcas.
Good morning,
Morning.
teacher. Is it possible to read completely up to here down, or I can end like on the third step, or yeah,
Oh, oh, here, no, Dorcas, it is always better you simplify to the dot where you cannot simplify any further.
oh, okay, teacher.
Eh,
Thank
oh, okay. Yes, Ara.
Good
Ara.
morning, teacher.
Morning.
Teacher, on the third step,
Mm,
after substituting, where we have x squared is e to the power 5x minus 3.
mm.
How comes we don't... Okay, where is the second e to the power 5x? Because there are two of them.
Here, this step here,
No, the third one.
here,
Oh, we factorized.
we factorized because it
Oh.
was common here and it was common here. Is it fine?
Yes, teacher, thank you.
Okay. Dr. Olive?
Good morning, sir.
Morning.
So about the answer,
Mm.
can you write it as x negative raised to power negative 4 e of 5
Mm-hmm.
into bracket 5x minus 3.
Mm-hmm.
I
It
mean,
is
we put
okay.
the denominator to the numerator.
You do what?
We transfer the denominator to the numerator,
Mm.
and then we change the power 4 to negative 4.
Okay, now when you look at the function that was given to us was in a fraction format. Now
Okay.
your answer would be better if you leave it also in a fraction format.
Thank you.
Yeah. But what you are mentioning is mathematically correct.
Okay, thank you.
But this one is more visible than the one you have mentioned. So when someone is calling, you can easily see this one clearly than the other one.
Okay, thank you, sir.
Okay. Yes. Okay. I think the last one is Arnold.
Good morning, sir.
Morning.
I was requesting for more inquiry on the second part here. Let me see.
Which part?
Actually, there of u is equals to e to the power 5x. When we're differentiating, for example, y is equals to e to the when we were differentiating y is equals to e to the power 5x, we first the fraction, I mean the power, and made the new equation formed as y is equals to e to the power u, right? But here I thought like we're going to do the same since we have e is equal to the power. E is equal to u is equal to e to the power 5x. We're going to be like u is equals to e set to the power t. Then we carry out factorization. But
yes,
I thought
Arnold, that is what we did. But like I told you, those are like the first steps. But the moment you master, there's no need for you to do all those things. Is that fine? But once
Yeah.
you follow that procedure, you'll get the same answer. But like I've told you now, for such functions, these ones you must know how to differentiate them quickly. Without going through the chain rule I was showing you how it comes about.
Yes.
So now you master. Okay, Arnold, before even you drop off, just imagine you had this. What could be our answer?
I think 3 e to the power 3x.
Yes, yes. So for those functions, you quickly just differentiate them.
Yes.
Okay, okay.
Thank you.
Julie? Okay. Julie?
Good morning, sir.
Morning.
Teacher, I'm confused on the v squared.
On?
Like that v squared on the quotient rule. We are having x power 3. Then outside the bracket, we are having that 2. I thought that, okay, I'm confused. Should we
Which one
add or should,
here?
yeah, that one.
Hmm.
So now I'm confused. Should we add or should we multiply?
Remember, x power 3 squared means x power 3 times x power 3. Now, when it comes to numbers of the same bases, we add the powers. So it is x power 6. Or x power 3 squared. If you are to use the rule, you have to say x 3 times 2, which gives you x power 6.
Okay,
If,
thank you, sir.
if you are to add, you first expand them in this format. If it is like this, you can as well just multiply.
Thank you, sir.
All right. Okay, okay, okay. Why don't I give you another one? Another one is here. I know you have looked at beautiful ones. Let me give you another beautiful one to try out, because now, what about when I have y? What's happening to my pen? Y is equal to e power x minus 1 out of e power x plus 2. So this is the one now we are trying out. Still, we are going to use our chain. Yes, Arnold?
Oh, sorry, sir. I forgot to put my hand down.
Oh, okay, okay, okay. So me, I'm waiting for the answer you're coming up with. You. I don't know whether I should even give you the format of how that I would love the answer to look like, such that people aim at getting. So we are going to aim at getting the answer of this nature. 3ex So that should be your targets. That should be your targets. Once you get there, we shall be very safe. Okay, at least I'm saying members are getting there. Got the same answer. It's what I got. I have that. You got the same answer. Teacher safe to go. Finished. I got it. Thank you. Thank you. Anyone finding a challenge? Anyone finding a challenge? Or all of us are very good to go. In case you are getting some challenge, we can support you because we may not do the number. Yes, Dr. Jimmy?
Master, I don't know where I'm making a mistake, but I'm getting 3e power x into ex plus 1, then out of the same denominator.
What was your u?
My u was ex minus 1.
Differentiate for us this to get your du dx. What did you have?
Ex. E power x.
Ax. Then what was your v?
Ex power ex plus 2
What was your dv dx?
was ex.
Ex. Okay. So we have our dy dx equaling to v du dx minus u dv dx out of v squared. Substitute, what was your v?
My v was ex plus 2.
Into, what was your du dx?
X.
E power
Ex.
x minus, what was your u?
My u was e power x minus 1.
Then your dv dx?
Was ex. E power x.
F ex power 2 squared. Okay, open brackets here.
Now, when we multiply those exponential, do we get ex squared? E power x squared.
First remind us. A power B times A power C. What do we have?
It is a power b plus c.
B power C. Now we come back. E power X times E power X. What do we have?
Okay, it will be e power to x.
2x. Like you add x plus x. which gives you e power 2x. Okay. We continue. So what shall we have?
So I have e power 2x plus 2e.
Good. We come here. This
Minus
one you can first even put this such that you don't confuse. Minus
e power 2x minus ex.
Okay.
Out of ex plus 2 squared or squared.
Okay. Open the bracket.
Then we shall get negative e to power 2x plus ex.
Okay. Out of
Ex plus 2 all squared.
Okay. Hope you are seeing the answer coming.
Yes.
Okay. Okay. What was your mistake?
I had made an error here where we multiplied the ex. I got it to x squared instead of 2x.
Oh, okay. Okay. Okay.
Thank you, sir.
Okay. Okay. Members, are we good to continue? Is everyone happy with that? Okay. Dr. Jimmy. Okay. I think we are finished. Yes, Docus?
Excuse me, teacher.
Hmm.
Is there this denominator can
Is
undergo
there
further
what?
expansion? Is there any way this denominator can undergo further expansion?
Hey, the denominator?
Yeah.
Yeah, it can. It can. You can expand. Though now here we don't need, but you can expand it. And when you expand it, you'll have something like this. E2x plus 2ex, then plus 4.
Oh.
Hmm.
So when you're working out for these things of depreciation, you should end here.
Yeah, you end here. No need to go and expand.
Thank you, teacher.
Okay. Okay. I need to check. Okay. Now, what about, because now we have done some, I want to give you the mixture. I want to give you a mixture. What about when, first take them away. Let me first take those mini scenarios away. So what about when I have this? Y is equal to E 3x minus 8ex plus my 5 of x. Can you differentiate for me that? Can you differentiate that and we see what we get? When we finish that, the last quick one is going to be this. Y is going to be, the last quick one is going to be 2x plus 3e. That's going to be our last one, those two. Those two. Okay, okay. There is also another one. I will check. Okay. Yes, Dr. Jimmy? Okay. Who wants to give us the answer for the first one? Mm. Okay. Linda?
For the first one,
Uh-huh.
we differentiate dy dx. We shall, if we lower the power here, we get 3e of 3 of x minus 8e power x plus 5.
Plus 5. Thank you. Thank you. That is good. People have already got the answer. Then for the second one, okay. Dr. Peace?
Yeah, for the second one, when we differentiate, we have y dx equals to 2, 2 plus 3 root x
3
root
root.
e. Sorry, sir. First, you first rub off that last part, yeah? So we shall have, that is, root x is the same as x power half, eh? So when we differentiate x power half, we shall get a half of x power, a half minus. In fact, I had made a mistake. That's why I'm.
So let us first put it a bit here and you tell us again. When you differentiate this, let me say with respect to du dx, what do you have? You
That
can
one we
first tell
shall
us, use
a
this.
half.
This one is the same as x power, a half.
Yes,
So what shall we have?
we shall have a half x
A half x. What would be our power? Oh, I think we have lost the Dr. Peace. So Ruth,
Okay, so we differentiate that. Okay, it becomes a half x power negative a half.
okay.
Then we multiply it by 3. This okay, we come back this side, so it becomes 3 out of 2. Then e of root x.
Okay. Can we write it? Continue.
2 plus 3 out of 2 x root negative. Okay, I'm going to simplify in the next step. Negative a half e of root x. So we remain with 2 plus 3 out of 2 x, 2 root x, 2 root x. Then e close to 3 there, yeah. Yes.
Oh, yes. So at least this is the answer. This is a beautiful answer. If you remain with that answer, thank you, Ruth. Yeah. Yes. So members, you take this a half down, like you say 1 out of x power a half. And then x power half is the same as 1 out of root of x. Yeah. Even if, by the way, let me give you one more quick one. You do for me this one quickly because sometimes you'll find let me say 1 out of e power 3x. You may find something like that and then you say, how do we differentiate this? You do it as a quick one and we see. Yes, Matia, that was okay. Hope everyone we are on the same page. This is the quick one we are doing. Okay. Okay. Okay, but Dorcas, we can make our answer beautiful. Dorcas and Gilbert, let's make the answer is correct, but can we make it beautiful? Can we make it beautiful? Sunshine, your answer is correct, but it's not yet beautiful. We can make it more. There's something. Thank you, Ruth. Samsung, yes. Hannington, yes, yes, yes. Yes. So when let me say they have given to you in a fraction form, in case your answer you are getting can as well be written in that format, always go back and also write it in that format. So members here, you first take e to become power 3 negative x. Then that's when you differentiate, you have your dy dx equals to negative 3 e power 3 neg x. But now this one, you make it beautiful. So you write negative 3 out of e3x. Now this one is much, much, much better. But your answers were correct, but we needed to just make them beautiful. Yes, Sunshine. Now that is very okay. Matia, yes, yes. Okay, I think now we can look at some mini scenarios. Now, this topic here of exponential is going to be very key in areas of one, in the areas of economics. We shall look at, I don't know whether here we have people who do economics, but we shall have some scenarios in the economic world. Things of elasticity. I know you have looked at elasticity, inelastic. We shall have some scenarios in that format. Equilibrium. We shall look at how we determine some of those things in a scenario format. We shall as well look at things in the physics world, as well in the engineering field as well. But also those people of biology, we are going to apply it, yeah, more so when it comes to modeling. In biology, there is a lot of modeling of, let me say, how these diseases spread, the bacteria, and the rest of that. So it's going to be very, very key. So we are going to first look at a mini scenario, a small, small one, and then as time goes on, we shall keep making them big, big, big. And when the time comes, you are going to apply it a lot when it comes to differential equations. Because when it comes to differential equations, we model a lot of scenarios. We may even model now, like currently, how a rumor spreads using this mathematics. Like when you want to know how the rumor spreads, how many days it will take for a rumor to spread from you to another person, then we can be able to utilize some of these functions. So we shall look at that. Now I have my mini scenario here. I'm going to ask you, why don't you first try it? Try part A and part B. Yes. And now when you look at part A, they're asking us, what is the price of the commodity at t equals to 0? So can you first find that, everyone, and tell me what you end up with? Okay. From in place of T, yes. Yes, people are getting $12. Very good. Okay, we can start on part A. Now, part A, they told us what is the price of the commodity at T equals to 0. They told that the price of a certain commodity in dollars per is measured given by that. So where there is T, put 0. So that means we shall have our part A having P equals to 8 plus 4 e negative 2t plus t e power negative 2t. In other words, this P is written in terms of t, so when t is equal to 0, we shall have 8 plus 4 e power negative 2 times 0 plus 0 times e power negative 2 times 0. So this will give us 8 plus 4e negative 2 times 0 is 0 plus here you get 0. Now this is where members may go wrong. E power 0 is equal to 1. Anything to power 0 is always equal to 1. So you end up with 8 plus 4 times 1, which gives us our 8 plus 4, which gives us the 12. Then you conclude that the price of a commodity is equal to $80. Don't forget, we are given in dollars. So here we shall have $12. So don't forget the $12. Then when you look at part B, they ask you, how fast is the price of the commodity changing? Now here, indirectly, they're asking you, whenever you are, remember, our prices are changing with respect to time. So they're asking you indirectly, differentiate. After differentiating, find how is the price changing. So this question is indirectly asking us, how is the price changing with respect to time? So members, let's differentiate. So you need to know now, they may not tell you, find the y, the x, find the p, the t. They will not tell you. They can ask you, how fast is the price of the commodity changing? So can we work it out? I'm going to first ask you, first try it out. First find out what is my dPdt. Now here, you let, since they have already told you P is the price. So that means I expect to get your dPdt. dPdt is equal to 0. Thank you, Dorcas. Thank you, Dorcas. They're asking you the rate at which the price of the commodity is changing when the time is equal to 0. People are getting some answers. Okay. Can we have someone to take us through? Someone to take us through? Okay. Okay. Let me pick someone. Yes, Rose.
Okay, dPdt
dPdt
is equal to,
is equal to,
when you differentiate, you shall get negative 8 exponent e to power negative 2t minus 2t exponent negative 2t.
negative 2t.
So according to our question, they say that t equals to 0. So we substitute
Okay.
negative 8 exponent negative 2 times 0 minus 2 times 0 exponent negative 2 times 0.
Okay.
So we shall get negative 8 times 1 minus 0. So our answer is negative 8.
-8. What are the units?
Dollars.
Eh? Rose, come again. What are the units?
Sharing the units in dollars.
Look, P is in dollars, right? Remember, you have
Yeah.
the PDT. Dollar think. What are the units?
Per
Are you
unit
saying
time. Dollars per unit time.
Per what?
Per unit time.
Not yet, not yet.
Actually, I don't know.
No, like you look at what are the units for the price?
So the price they are in dollars.
Then time.
In weeks.
In weeks. Good. So per unit time. Okay. So you have said dollars per unit time.
Time.
Okay,
Yeah.
that is good. So here you put dollars per unit time. Do you do economics?
No.
Okay, but now how will you interpret? Because now just imagine, how will you interpret for such a commodity? In case you have someone in economics or someone who wants to interpret for us this, you can raise up the hand and you support Rose. Anyone to interpret for us that a bit? Yes, Ruth.
So I don't do economics, but I can try. So
Okay.
since the rate is a negative, I think the price of the commodity will be, or rather, how do they call it? Okay, will be reducing by what, $8 every week.
Perfect. So Ruth, give us a good one now. Sum it up such that members can interpret.
Okay, someone has corrected in the chat. It's depreciating. Okay,
Uh-huh.
so the price of the commodity will be depreciating by $8 every week.
Ruth, are we safe? Okay, what is
But
depreciation? Depreciation is mainly
loss of value.
loss of value of what?
I don't remember of what. Actually, I don't remember.
Okay, let me
Okay, let
give you
me
an
use what I was
example. A
using before.
car. I give you an example of a car. We can say car
Yeah.
depreciates.
Oh, that as it keeps being used over time, if it's to be sold, its whatever, its price can't like remain the same, like from first hand to second hand and so on. Okay,
Yes.
let me use decreasing.
Okay.
Okay, so the price of the commodity will be decreasing by $8 every week.
Perfect. Okay. Thank you, Ruth. So that's how you interpret it. So you go on and write that interpretation there. Okay. Yes, Samsung.
Yeah, teacher, I'm asking there.
Hmm.
Could I also say that the price is fluctuating by $8 per week? Would the conclusion work?
You tell us about fluctuating. First, teach us about fluctuating.
Decreasing of a commodity.
Decreasing of the
The price
commodity.
Yes.
Okay. I think that one is also very okay. Lynette, thank you. That is okay, Samsung.
Okay, sir.
Hey, wait, someone is telling us that fluctuating means rise and fall, I think. Right?
Sir, what about price inflammation?
Which one?
Price inflammation. I think for price inflammation, it's the increase. It's when the commodity increases.
The commodity?
increases when they say of price fluctuation.
Because fluctuation means a change in the price, right?
Yes.
Because when you look at price fluctuation, it shows how the price changes over time. So it can either be a rise, it can either be a fall, or it can be a stability. Now, when it is negative, negative shows you clearly that it is a fall.
But
So,
excuse me, sir.
mm,
What about, I think, I thought that they said price inflation, it means now the price is increasing, but for
now,
price to,
now you're bringing the word inflation.
yes, I think for that one, it's when it is increasing.
Okay, at first you mentioned fluctuation, right?
Yes.
Now you're bringing inflation.
And teacher, you're saying that for fluctuation, it is increasing and decreasing.
Or stable. It is either three. It can be either stable, it can either fall, or it can rise.
Okay, sir.
Then in case it is inflation, inflation is about increase in the price over time.
Yes.
So meaning here, we cannot use the word inflation, we cannot use the word fluctuation.
Okay.
Even the word depreciation, we cannot use it. Reason being that we are not sure which kind of commodity we are dealing with. Unless maybe in case it was a car, that could be understandable because there are commodities that depreciate over time. So here, the best would have been decrease, that the price decreases, or you can use maybe fall by 8%. Like you have those commodities whereby every week the price keeps on dropping. An example you can use, those success cards. As time goes on to December, their prices keep on decreasing over time. Okay.
Okay, sir.
Okay, Samsung. Yes, Melissa.
I don't know, but I felt it's like as if I see some product rule here on T is equal to exponential negative 2T. I don't know.
Yes.
Isn't that product rule?
Here. And here, I'm not saying as if here, right? So I think here we need to look at how we differentiated. Because let me first put a plus here and I check out. I don't know that she just jumped it because it was when I keep t, I differentiate the other one, I get negative 2et. Then when I keep the other one, I don't know whether members are not seeing because now I'm not seeing something. This is keep t, differentiate this. Then when I keep the other one, I'll have plus e negative 2t. Do you have that?
Yeah, I
Remember?
have that.
So this becomes negative 2t e, right? Of t, then plus e power negative 2t plus negative 8 of negative e to t. Okay, I think I can first go back a bit. Members, can we first check out our answer, how we are differentiated? Because I'm saying this answer is going to change to 7. It's going to change to 7. I don't know if the members have noticed that. So here, you end up with negative 8e negative, okay. Let me first remove this. So this is negative, I don't know it, negative 8e to negative t plus e negative 2t minus 2t e power t In fact, this is negative 2t, negative 2t. So negative 8 plus 1 gives us a negative 7, e of negative 2t minus 2t e power negative 2t. So here the answer is supposed to be 7, not 8. Thank you, thank you. I don't know whether members have noticed that. Melissa, were you getting 7?
Yeah, I was getting 7.
Okay. Members, have you seen the correction? This is supposed to be negative 7. Thank you. Thank you, Melissa.
Okay.
You call me later. Call me later. First, call me in about 30 minutes. I'm in a lesson. Okay. Okay. So, hope members have seen that correction. Let's make it. So here, we are going to stick that it is decreasing. And then you say at a rate of 7, then dollars per time. Okay. Even I'm seeing people of chemistry here. They are bringing in their things. Okay. 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 I think we are good to go. Are we good to go? Have we seen the correction there? Are we good to go? Dorcas, Lillian, I want to know whether we are good to go.
Morning, teacher.
Yes, morning.
For me, I'm not getting it. Why do we have here t negative 2e power negative 2t?
Oh, it comes from here, t e power negative 2t. This is your u, this is your v. So you have u dv dx plus v du dx. So your u is t, v is e power negative 2t. So when you differentiate, you have dv, are you seeing it? The t, which is negative 2e, negative 2t. So that is what we have here. Have you seen? Plus v,
Yes, teacher.
which is e negative 2t, but your u is equal to t. When you have the u dt, you get 1. So here you have a 1.
Oh, thank you,
So that's
teacher.
right. Okay. Dorcas? Yes.
Please help me understand. Like, when do we consider the
Come again, you're saying?
okay, like when do we consider the coefficient of the exponential? Be
How do we?
when do we
Mm.
consider the coefficient of the exponential a constant or like to be like you like to be like something like
Oh, when do we consider? Now, when we look at, when you are differentiating with respect to time, the coefficient, as long as it is t something, you consider it. Are you getting it? But if the coefficient is different from this value you are differentiating with respect to, you don't consider it. An example, in case I have a e power negative 2t, this is a constant, I don't consider it. But if it is t squared e power negative 2, then this one I have to consider it. Okay. Dr. Peace?
Teacher, I'm just asking because network was disturbing me here where you got the PDT. Is it the beginning of the calculation of part B?
Yes, yes.
Okay, thank you.
Okay. Last is Samsung.
Sir, my question is like for that equation of P, that means we would first differentiate each thing independently, then we sum up last.
Perfect. Perfect. I agree with you.
Okay, sir.
Okay. So members, I think we go on to another one, such that we also consider people of biology, Yes, people of biology, now we are with you. So this one will be taken by biology people. Biology people, you'll be the ones to take us through this. And you'll be the one to explain to us. But also physics people, I know. These are your things as well. Oh, hope we are trying it out. Hope you are seeing how now they keep on changing the language. Here now they're asking, find the rate at which the mass is decreasing. Now you need to know that when it is rate comes from the word ratio. But whenever it is rate, we always, the variable is always time. So I'm happy every department here, the physics, they have their language. The biology people have theirs. The chemistry have theirs. No, even people of physical chemistry are coming. Okay, okay. So let's first and check out which answer do we have, and then we interpret. So here we shall have applications in those subjects. I know here we have people of physics, we have people of, I know we may have even ant people, yes. So we shall have examples from all those subjects. I don't know how people in ant call that, but for this one, I know it's mainly chemistry people, biology, and the physics that are going to be talking. Okay. People, I'm waiting to look at your answers. I'm waiting to look at your answers. To look at which answers are we coming up with. Negative 0.02832. Sophie, you can raise up as people are trying finalizing. And here, don't expect a beautiful answer of 2, 3, 4. The answer may have points. Yes, Sophie?
Teacher, I'm sorry. No, good morning, teacher.
Morning.
Teacher, I came in a bit late. I'm not completely lost, but then I want to know like which topic are we handling? I'm just kindly requesting to know.
Differentiation.
Oh, okay. Thank you so
Eh,
much.
Okay, but first differentiate for us this one to check that you have at least picked something from the lesson. Sophie, come back, Sophie. Yes, Sophie?
I'm going to first work it out. I've not yet worked it out.
Hey, you tell us, let us follow your steps on what you are going to do as people start. Uh-huh.
I think we are getting the MDT, is it? I don't know.
Perfect. The
Then,
MDT.
yeah. Then, I think we are going to, according to what I remember, the few knowledge I have, I think we're going to drop this one, like the negative 0 point, is it 0 point what? Firstly, I had that one. Then we multiply by the 300.
Mm.
Is it? Mm. I, d- I don't know. I don't know what
Then
to
we
do
bring,
next, teacher.
then you bring back the original function you have differentiated.
Oh, okay.
Hope you like when you differentiate this, that's why you got
Mm,
this.
okay, teacher. Then,
Uh-huh.
teacher, do we substitute the T like from up that side? Like with the
Yes.
2000? Okay,
That
teacher.
is okay. Can
Okay.
you first tell us here what you get in a simplified form?
Let me see.
Okay. 0.36 e power negative 0.00012t. So when you put in your 2000, I'm seeing members getting that answer I've seen in the chat times 2000. So times e. Okay. Yeah. Now we are going to look at the interpretation. So people of biology, you can start raising your hands up and you tell us how do we interpret and what could be the units here. What are the units? People raising up the hand, you are going to tell us the units and then you tell us the interpretation from the biology angle, how you interpret this of physics. Okay, yes, Ruth.
Okay, so the units are grams per year.
Grams per year. We agree with you on that.
And okay, this is physical kill and the radioactivity. So that's going to be the interpretation is that this is it's called a decay constant, whereby for this radioactive substance to disintegrate or to decay, it releases a certain amount per given time. So that constant or that rate is what we call the decay. It's what we call that lambda. It's called the decay constant. Yes.
Okay. How would you interpret and write your conclusion?
Now my answer. Okay. So the at which the mass is decreasing when T is equal to 2000. Okay, so the mass will be decreasing by negative 0.0283 every year.
Okay. I come again. I'm coming to ask you. You have mentioned decreasing. You have mentioned a negative again. What do you have
Sorry.
to say about it?
Sorry. I eliminated the grams, but I forgot to eliminate the negative. Sorry. So it's going to be, the mass will be decreasing by 0.0283. Okay, let me say it again. The mass will be decreasing. The mass of the radioactive substance will be decreasing by 0.0283 every year.
Okay. Thank you. We have another doctor here. Thank you, Ruth. We have another doctor here, Dr. Jimmy. According to what? Which subject?
It is chemistry, according to I'm saying that the mass at which, okay, when I start from the question, it is the mass is decreasing at a rate of 0.0283 grams per year.
Okay, good. Yeah. So I think those are the different interpretations we can have. And I think all of them agreed. Those people from biology. Yeah. Yes. Yes. Please, the decimal places, at least they should be three. They should be three. Yes. They should be at least three. At least three, a minimum. Oh. Dr. Peace is saying we call it negative feedback mechanism. Okay. We are learning from you people. Okay. This one, you'll try it in your free time. This one, you'll try it in your free time. Take a screenshot. Okay. I'm going to take an assumption that people have taken a screenshot. Now that people have taken a screenshot, why don't we practice these numbers? You may not do all, but you can pick and say, let me do this, let me do this, let me do this. Just to test ourselves that we have mastered. Okay, now that people have finished to take a screenshot, allow me to add you more. Just you pick a few, you say, let me try code this one, let me try code this one. And you need to be able to know how to go about with the different rules. You try one that requires you to use the chain rule, the one that requires you to use the quotient, the one that requires you to use the other rule. Yes. Then, if you get those answers, then that will be very fine. If you get those answers, that will be very fine. Just take a screenshot of the answers. Once you get them, we shall be very safe. All right. So, yes, Trisha? Trisha?
Sir, could you please take back to the previous slide?
Here? Okay.
Yes.
Have you taken?
Not yet. I'm now done, sir.
Okay. Yes, Wafla?
Good morning.
Morning.
I was just inquiring, are these lessons also going to be on for next week?
Oh. Okay.